Okay, good morning, all of you. Today we'll see the soft computing techniques. So, in the previous class and all, we have see the some of the swarm intelligence. So, in that we will see now there is a soft computing techniques. In the soft computing techniques, preferably we'll call it as a SC or a soft computing technique. It is built in intelligent and machines. So we need to build a intelligent machines. Intelligence provides the power to derive the answers, not simply I can see here, mm, not simply arrive the answers. It has to derive the answers. Purity of thinking, machine intelligence, freedom to work, dimensions and complexity, fuzziness, handling capacity. These are all going to be advantages. Handling capacity will increase as we go higher and higher the inherency. So this computational techniques, if I use any of the application, automatically we can able to get uh, you know handling capability is going to be increased. The final aim is to develop a computer or a machine. Normally, we call it as a machine, which will work in a similar way of human beings. This is what the soft computing techniques will do. Whatever we are going to use for any type of application in the soft computing technique. Finally, this has to be developed as a machine model. How the human will work, or it will be trained, or it will learn from the experience and learn from the errors. So it will adjust their results. All these things is going to be happen in the case of soft computing techniques. That is the reason we can say it is a it's like a human brain. The soft computing is a collection of methodologies. There is a different methodologies. uh, in uncertainty also will be there some cases, and partial truth, it will not be exact truth or something. Your imagination also, some parameters we are taking as a random parameters and all. So partial truth to achieve the robustness and low cost. The And one thing, while you are using the conventional methods and all, what we can do is the lot of computation is required, and accuracy will be straight away, that we cannot predict anything there. We'll get directly as a results. So that is the more different version. In the analytical methods, soft computing methodologies mimic the conscience and the cognition in several important aspects. So we'll see that in the how the soft computing is evolved. Normally, initial stages, there is a hard computation techniques will be there, or you can say that conventional methods. That may be Newton's method or any normal method, linear programming or non-linear programming, quadratic programming. All these things we call it as a conventional methods. And after that, there is a soft computation techniques evolved in different stages. We call it as sometimes the intelligent computers, then consciousness modeling using computers, and then or you can say that purity, freedom, and dimensionality. So all these things is going to be improved level by level, because in the research start in the conventional methods. After that, it is evolved as a soft computing techniques. In the soft computing techniques, we may have the different strategies, whether it is a genetic algorithm or fuzzy logic or evolutionary algorithm or heuristic techniques. Like that, it evolved as a many stages. And this is the way the soft computing evolved. It's like to play an especially important role in science and engineering. All engineering problems nowadays we are using as a soft computing technique. but eventually it influence many extend much further. That is also possible in the soft computing, differs from the hard computing in many ways. Because anyhow, after this, we will see the comparisons between conventional methods, and then spam methods are also called as soft computing method, or we can say that hard computing and soft computing mechanism. In the soft computing, some cases, not accurate, or you can say that it is not a fixed answer also. When we are changing or running the program, it will get in the different stages, in the different answers we may get. But we can get final answer by running the many types of algorithms and all. Now, runs based on the populations. This is the, for example, you can see the soft computing exploits the tolerant of impression and uncertainty, and then partial truth and approximation. This is the case in the soft computing, partial truth, but whereas in the case of conventional, there is a exact truth, and there is a lot of approximation. In effect, the role model for soft computing is the human mind. This, as I said, now soft computing is always like a human mind, like how the humans will behave. These algorithms will behave like that. We'll see the lot more differences, and what are the algorithms is involved, what type of problems we can use solved using these algorithms, like that. There is a collection of techniques spanning many fields that fall under various categories. As I said, it is not only the science, and all engineering departments are using this soft computing techniques. There is a three main branches in the soft computing. One is a fuzzy systems, another one is a evolutionary computing, another one is artificial neural computing. So like that, we have different approaches. With the later nowadays, there is a machine learning, deep learning techniques is improved. This is still better than our heuristic techniques. Here we can easily predict whether we want to know the forecasting, or anything, the bills in the next year, or what is the radiation in the so and so date. All these things we can easily do that. That is in the case of machine learning. And probabilistic reasoning and belief networks chose theory, parts of learning theory, and wisdom based expert system. So these are the some of the things. Now that's what I mentioned here. Soft computing techniques. There is a lot of soft computing techniques in, by the way. So not only the conventional thing, after conventional, it is evolved as a soft computing mechanism. In that case, there is a one thing we can observe here. There is evolutionary computing, that is we call it as EEC, and machine learning is there, neural network is there, or artificial neural network, or simply neural network, we call it as a fuzzy systems are there. Probabilistic reasoning, that is all PR. And another one you can see here, wisdom based expert system, WES. So these are the some of the soft computing techniques. So in that, in turn, may have as a many type of algorithm that also we'll see here. The computational intelligence, the broadly we can say that genetic algorithm, and artificial life, and then fuzzy logic, and spam intelligent. This is the very popular normally. A spam is nothing but a group of agents. As I said in the last class, instead of solving one person, what we can do is we'll make as a group, our agents, our individuals, what we call it as that group of members or group of individuals together, they solve that we call it as a spam intelligence, and then neural networks, and then there is evolutionary algorithms. Like that, we have different kind. So same another way of classification also you can see. There is a category of different soft computing techniques. Soft computing broadly divide fuzzy set and neural network. Neural network again dividing as artificial neural network or feed forward or like that. We have many. That also I will show you. And evolutionary computing. In the evolutionary, computing technique, you can use genetic algorithm, genetic programming, and spam intelligence. And this is very popular now, and a lot of techniques we can involved in that. The particle spam optimization, ant colony, cuckoo search algorithm, like that. We will get a lot more algorithms in the spam intelligence. Here the spam either may be person or maybe insect or something, like animal. Based on that, we are able to generate our logic, the nature of the bird or nature of the animal. Like that, we are able to develop the algorithm. That algorithm, we are applying the actual problem, a real world problem, to solve that problems. So another, you can see this is the best way you can, if they asked, explain the, or you can say that the classifications of soft computing technique, then you can represent this way. It is a mixture of all the things. What we can observe in the soft computing technique, there is a, just a minute. Yeah. So in the fuzzy computing, that again dividing as a fuzzy set, fuzzy logic, or fuzzy theory, or there is a fuzzification, defuzzification, like that. We have the, in turn, we are going to use some more equations to get the fuzzy computing. Another one is a neural networks. Neural network again dividing as artificial neural network, recurring neural network, back propagation, and feed forward neural network. Like that, we may have different kind of neural network. All comes under the soft computing techniques only. And evolutionary computing, in that, as I shown you in the previous slide, majorly we can have a genetic algorithm and evolutionary algorithm, differential equation DE. In our case, the second unit itself is a DE, and another unit, I mean, second unit is genetic algorithm. Then another will go for as a DE and BSO, like that. We are going to elaborate each algorithm, whether it is a evolutionary algorithms or a spam algorithms or anything. So now, we can see that in the machine learning nowadays, machine learning is a lot of improvement. We have is a supervised learning, unsupervised learning, and semi-supervised learning, reinforcement learning, like that. I think you are familiar in this different kinds of machine learning techniques. And similarly, swarm intelligence, ant colony optimization, particle spam optimization, firefly algorithms, like that. We have the different kinds of spam intelligence. So just a minute. Yeah. So these are the some of the computational computing techniques in the soft computing. We broadly classified fuzzy, neural, evolutionary. Another one is the machine learning and spam intelligence. These are the some major soft computing techniques. So now we'll see there is a broad, different kind of classifications. Soft computing is a partnership in which each of the partners contribute as a uh, distinct methodology for addressing the problems in its domain. So, as I said, instead of individual is going to solve, normally it will be as a partners or a group of members. So that together they are going to solve the problem. So that is only the advantage of soft computing technique. Importance of soft computing technique, as I mentioned, the different algorithms I shown you in the previous slide. Combination, some algorithms normally they can do individually, or some algorithms they can work together also. A striking example of particularly effective combination is what has come to be known as neurophysics systems. So in this combination, you can see fuzzy systems as well as the neurophysics systems together. They're using. That's what I can say that hybrid algorithms and all. So what they will do is individually they can able to mixed. So why they have to mix? Because some algorithm they have their own advantages, some algorithm they have disadvantages, like that. The all different algorithms advantages make as a one hybridization, so that our problem will be solved effectively. That's what here neurophysics systems also is. Such systems are becoming as a increasingly visible and consumer products, ranging from air conditioners and washing machines to photocopiers. All this kind of applications we can use that hybrid algorithms. One of the important feature in the soft computing, you can see that there is a knowledge and information mm, from inaccurate to uncertainty data. From inaccurate and uncertainty data, in that case, we can able to use this. Soft computing is often robust under noisy input environments and has high tolerance for impression in the data on which it operates. Now, main components of soft computing, you can see there is a inspire from natural phenomena. So, thus all soft computing methods are evaluated by inspiring the natural phenomena. There is a neural computing tries to mimic the animal brain. You can see here animal brain, and genetic algorithms is found on a dynamics of evaluation, while fuzzy logic is heavily motivated by high impression nature of human speech. And we'll see one by one fuzzy logic, all different kind of evolutionary algorithms and swam intelligence. We'll see just briefly, because all these units is first unit is only the introduction of all these computational methods. We'll see the fuzzy logic. The human beings deal with the impression and uncertain information as we go about our day-to-day routine works. So this can be blended from the language we use, which contain many qualitative and subjective words and phrases. While we are using, such a quite expensive, very young, a little for expensive, like that, some, speeches. So in human information processing, we use approximate reasoning to handle impression and uncertainty in the formation we deal with. So now the fuzzy system are a generalization of still Boolean logic. It uses fuzzy sets which are the generalized, the crisp set in the classical set theory. So now there is a lot of difference in a crisp set and then fuzzy set. The previous class also I quoted this. Crisp means either 0 or 1 or yes or no, like that straight away. But a fuzzy that will give as a membership value, it will not discard completely and it will give the weightage based on their features. In classical set theory, object could just be either a member of a set or not, like as I said, no, yes or no phenomena. In fuzzy set theory, a given object is said to be as a certain degree of membership, whereas in the fuzzy, it will give as a certain degree of membership. Degree means let the weightage is maybe zero point 0.2, or for this maybe zero point 0.3, some other maybe zero point 0.5, like that. We'll get the some weightages, but whereas conventional or crisp set, they will give directly yes or no concept or 0 or 1 concept. Hence, fuzzy set membership values of the objective could be in the range of 0 to 1. In that range, they will give the membership value. But in CRISP, we can see that membership value is always, the range is for fuzzy set, the membership value range is 0 to 1. But whereas in the CRISP, it has to be either 1 or 0. It will not be in between. Now, the fuzzy system, that is also called as expert system, consists of a fuzzy rule base, a fuzzification module, an inference engine, and defuzzification module. These are the some of the components inside the fuzzy system. The fuzzification model or module pre-process the input value submitted to the fuzzy expert system. So the data will be do the pre-process before going to the fuzzy expert system. Then the inference engine uses the results of fuzzification module after fuzzification and access the fuzzy rules to infer what intermediate and output value to be product. So normally there is an input. That input is given to the fuzzification that will convert into machine, understanding language. Then there is a defuzzification, there is expert system. After that, there is a defuzzification, convert machine model to human understanding language, or machine language to human understanding language, and it is given to the output. So this is the system is going to be process the inside the fuzzy set. So final output of fuzzy expert system is provided by the defuzzification module. So after defuzzification, because whatever processor system inside, that will be as a machine understanding language. After that, again we have to convert back to human understanding process, so that the defuzzification is going to be mm, give the final results. And this is what we explained here. If anything we want to control, whether it is a speed control of a motor or something, any control parameter, the desired value and actual value it has to be compared. Now, the data or input data will be pre-processing, then it will go to the fuzzification. After that, then fuzzy inference engine based on the rule based and all, because lot of membership uh, parameters are there. You can use the depends on the application, any of the membership you know parameters. Different kind of membership functions are there. Any function related to our application based on the literature, you can use the membership functions, and that will be given process is taking place. Then after doing this membership rule based and all, it has to pass through the deep fuzzification, and the defuzzification, then it goes to the post processing and given to the system. So like this, the process is going to be happen in a fuzzy system. And that is all about the first one, fuzzification, because in the soft computing, we have as a, different mechanisms. Briefly, I explained there is a introduction, or you can say that what you call it as fuzzy system, then artificial neural network, or evolutionary algorithms. In evolutionary, again, you want to can different kind of techniques, heuristic techniques. You can briefly discuss. And artificial neural network, simply call it as a neural network. But normally there is a ANN, or in general, neural network can be loosely defined as a large set of interconnected simple unit which execute the parallel to perform a common global task. These units usually undergo a learning process. So normally, this thing is going to be as a learning process, which automatically update the network parameters. Suppose by it is as I said now, human brain. Once the by experience, it is going to be learned. After that, there is a update process going to be takes place. Each parameter is going to be updated by iterative process or by experience, you can say that. uh, then some basic characteristics you can see in the neural network are NN or artificial neural network. Some characteristics it will be there. Inherent parallelism, but whereas in conventional methods, we cannot do multiple works at a time. There is no paralleling is, I mean, paralleling is not possible in conventional method. But here, there is a inherent parallelism is there. That is a practically all neural network model have some elements of parallelism. So it is the major advantage. You can say that exclusion of their neural components. Another characteristics you can see, similarity of components. So it is a very large extent. The basic components of a neural network look all alike of behavior similarly. Mm, then access to local information. So any given nodes level or they can exchange their information like ant colony optimization and all. How the ant is going to be such the food that is going to be exchange their information so that all other ants also will follow the path. That's what you can see here. Access to local information, any given nodes level of activation, and eventually output will be depend exclusively on its current states and the output of the other nodes to which it is connected. Um, Incremental learning and neural network parameters undergo several small changes and which over time would come to settle on their final values. So these are the some of the characteristics, or you can say that features. So now neural network models can be classified in a number of ways. You can see different classifications like no recurring network, feed forward, additive network. So like this, we have is a different another classification according to the network structure. We can say that fixed one and dynamic structure. And another classification according to the model of learning. So here the model of learning is nothing but a machine learning. That is supervised learning and unsupervised learning, semi-supervised learning, and reinforcement learning. So like that, we can categorize based on the mode of learning. And neural network models can be classified on the basis of their overall task. So the tasks to do this, we have another classification. There is a pattern association, classification, and function approximation. And evolutionary algorithms, that is also called as EA, which are inspired by the biological, that is the third category I'm telling. The previous one, there is a neural network, and before that, there is a fuzzy logic. And third one, evolutionary algorithm. In evolutionary algorithms are inspired by the biological mm, genetic found in a living nature, which is simple, powerful, domain-free, and probabilistic approach to general problem-solving technique. So here there is a most popular one. We call it as a genetic algorithm. Work with one large population in the recombination steps. So, in each individual may potentially choose any other individual from the population as a mate. So, we can see in this process there is a lot of members or group or agents will be there. Then individual can choose their mate as per their wish, and it may be better one or maybe sometimes it may not be. But finally, in this iterative process, by doing the searching, and final outcome will be best solution is going to be arrived. The genetic algorithm operators are performed to obtain the new child offspring, because the combination it will do, then another they can also get it as a another offspring solutions. There are three important genetic algorithm operators. These are the crossover, mutation, selection. So while we are doing the second unit, these three operations only we are going to perform to solve any optimization problem. Initially, we'll solve with some basic test functions. Later point of time in the fifth unit, all these algorithms we're going to implement using our you know techniques. The techniques, it may be not only one. It is a genetic algorithm and differential evaluation algorithm. If we go for spam side, we used a PSO, vertical spam optimization, or maybe uh, updated PSO or improved PSO, or anything modified PSO, whatever you call it. And in that genetic algorithm, while you're doing these three steps, is going to be as our flowchart. So simply as a crossover operation, then mutation, then selection. These are the three things you must do. And then hybrid intelligence system. What is the difference in the hybrid system and normal system? Whereas if I say some method, while you are doing like as I said in the power electronics, we have a lot of components. One is BJT, MOSFET, IGBT, MCT, SCRs, like that. Now, just to understand hybridization, in the form of power electronics, there is a IGBT device is there for the hybrid device. So in that, how the IGBT is going to be fabricated, you have to consider make use of MOSFET and BJT, because in our case, BJT we have some drawbacks, and MOSFET also we have some drawback. So to overcome these, or to go for a better solution, what we can do is we are using as a hybridization. So whatever the device in the BJT drawbacks and MOSFET drawbacks is going to be eliminated, or I can say otherwise, there is a what you call it as BJT advantages and MOSFET advantages together will form as a one device, that is a IGBT. Same fashion, hybrid intelligence system, this approach have proven as efficient than the individual system. Now we can see there is a fuzzy logic, neural network, and evolutionary computers computations are complementary methods. In design, we have as a design applications, then implementation of the intelligent system. For all the design approaches, we are going to use this kind of thing for intelligent systems. And we can observe there is a each approach has its merits and drawbacks. Normally, if any method if I use, we have some advantages as well as the disadvantages as well. To take advantages of merits and eliminate the drawbacks. So many ways we can do that, but what we are doing is here is hybridization technique include the integration of neural network, fuzzy logic techniques as will combine, then we can say that evolutionary method, new method is going to be evaluated. Same manner in the soft computing in emerging approaches to computing, to construct as a intelligent system. It provides the ability of parallel computing in a human brain. So this is the major thing. You can see in the literature also hybrid cuckoo search algorithm. What is meaning of there? The hybrid cuckoo search algorithm, normal genetic algorithm operator, one of the crossover operator is incorporated into cuckoo search algorithm. Then it become as a what you call it as a hybrid mm, cuckoo search algorithm. Similarly, you can mix with search algorithm with PSO, or you can mix with some harmony search algorithm with genetic algorithm. Like that, many combinations are going to add to become as a hybrid algorithm. But you can see the some strengths and weaknesses of different approaches. We have ANN I explained and fuzzy set I explained and the evolutionary algorithms. In that, we can easily notice what are the strengths and weaknesses of a soft computing techniques with the different cases. So first, suppose if we take ANN, learning capability and adaptability is more, and fault tolerance capability. Another one is a model-free approach. Then historical data needed for training. These are all the some strengths. And if we go to weaknesses, black box approach means input we are giving, we are getting output, but what will happen inside, that is not understanding concepts. So that system sometimes machine learning and all that will develop their own programming part. That's what we can say it is a black box approach. It can only handle then quantitative information. So if any what you call it as noise information and all, it will not work perfectly. No reasoning capability. And fuzzy set you can see there is the in the fuzzy also a lot of drawbacks also there. No learning capability. It can only handle qualitative information. And evolutionary case, convergence is slow near optimal solution. So this problem is going to be there in the case of different weaknesses. And advantages side you can see here, there is a systematic random search and provides the multiple solutions. As I said, in all evaluationary algorithms will provide multiple solutions because once the initial status itself as a random search, that is the reason I will get it as a different kind of random. So knowledge representation in the form of rules, fault tolerance capability, expert knowledge is required. So all these kind of merits as well as the or you can say that strengths and weaknesses will be there. And as another topic, because we have seen some conventional as well as the SWAM computing, so that we can compare all the parameters. So in this comparison, conventional versus SWAM are related to as a soft computing in broad way, requires program to be written. In the case of hard computing, like manual program has to written and to get it as a solution. And SWAM can evaluate its own programming, like a machine learning and all, and it can only deal with exact data. Because if any data is missing, manual calculation, it will not get any perfect solution. That's the reason it will always deal with exact data. And whereas in the SWAM case, it can deal with ambiguous and noisy data also. Some data may be missing and some data may be redundant, and some data may not be used properly. So for all that kind of data also, it is going to be useful. It gives precise results. In hard computing will give directly accurate results, but whereas in the soft computing, it gives approximate results. It is also called as a conventional intelligence system. That's what I mentioned is a conventional, but in this case, computational intelligence or mm, that is a conventional intelligence and then computational intelligence. It allows sequential computing, but one by one only it is going to be. Whereas in the case of soft computing techniques, as I mentioned in the previous slides, also there a parallel computing is possible. Requires a lot of computational time because this conventional methods a lot of computational it has to do. Sometimes is a different kind of differentiations we need to do, then Jacobian mismatch, then error identification, then you have to do the lot of repetitions you need to do. That's why it will take a lot of time, but requires reasonably less time when compared to the conventional methods. High cost for solutions. So because of this reason, it will take a lot of time and then cost effective in the case of conventional, but it is a low cost solution. It is require full truth. It will get as a full truth, but whereas it can be partial truth, it will be deterministic solution will give, and probabilistic solution in the case of soft computing, and based on binary logic it will operate, and whereas here based on the fuzzy logic and neural network and probabilistic reasoning methods. And some applications you can notice here, there is a used in critical system, numerical analysis and real life application. In this case, soft case, uh, handwritten recognition. Sometimes, as shown in the first class, I think while you are writing different letters, the system is going to be identified. Whenever, suppose if I write here something in the handwritten, the system is going to write what are the letters we wrote there. So that is a handwritten thing is going to be identified. Another one, image processing, decision support system, automation systems. For all these kind of applications, we are going to use this soft computing techniques. So now I will stop here. The only one class may be left out, or maximum two. So we'll complete this unit by end of this week. So if you have any doubt, you can ask me. And I request all of you to come to college on Saturday to discuss about mini projects. Yeah, anything you want to say? If if you have any clarification need, you can ask me. Otherwise, you can leave.